All right. So there's a few addition and subtraction problems, and then we're going to look at them in some more complicated situations, kind of like we did yesterday. Sorry, this doesn't always zoom how I want to. All right, so first we're going to focus on something that looks more like this. This is more similar to what I just showed you on the backboard because there's no terms. Look at the denominators. Do you guys see what I'm saying when I'm saying there's not any terms? The denominators are monomials, right? They're just one term, which means everything in there, the A's, the B's, the 5, the 3, those are all factors because they aren't being added or subtracted with anything else. So we don't really have to factor anything in this problem. This is just going to be practice with, if they aren't numbers, how do I figure out like the least common denominator? So that's the first thing we're going to look to find, is that least common denominator. So when you look at the first fraction and you look at its denominator, you need to contain all of those things. Remember, all you're doing is multiplying in extra stuff to make a least common denominator. You're not able to like take things out. So we're going to need a factor of 5, a factor of A, and 3 factors of B. All I'm doing is looking at this and saying, hey, this denominator already contains all those things. None of them cancel out in this fraction. So if I'm going to find common denominators, I'm going to have all these things and possibly some extra stuff, right? So then look at the next denominator. Okay, numerically, we've used a factor of 5. Here we have a 3. We don't have a factor of 3 yet, and this denominator has a 3. So we have to also include a factor of 3. Then this says a squared. We have written some a's, so let's see if we have enough. The fact that the second fraction says a squared, that means it already contains 2 factors of a, and we need to make sure our common denominator also contains at least 2 factors of a. So far, our common denominator that we're putting together contains 1 factor of a, so we're going to need to put in an extra factor of a. Okay. And then when we look at b, in the second fraction, the denominator, b has 2 factors in that denominator. We already have 3 factors of b listed here, so we already have more than enough to cover what's already in that denominator. So these are the factors we're going to need to make our least common denominator, which in a more simplified form means our least common denominator is 15a squared b cubed. And if you saw that before this, and you're like, Ms. Dahl, I don't need to write all of that out, I'm totally okay with that. I'm just trying to make a point as things get more difficult that if we use this method, we can use it in the more difficult context. If in the easier context, when there's less things going on, you guys feel like you can do it another way, that's fine. I'm just going to try and be really consistent to reinforce the idea of how we're putting together the least common denominator. So then we want to see what's missing for each one. So this one had 5a and 3b's, so it had all of this, but is missing a factor of 3 and a factor of a. So that first fraction, we're going to multiply in an extra factor of 3 and a. And if we add those extra factors in the denominator, we also have to multiply them into the numerator. That way we haven't really changed it, right? What we've really done is multiplied by 1, because this over this is just 1. And things times 1 are still themselves. So it's still itself. We just made it look a little bit different. And then the second one has a factor of 3. It has 2 factors of a and 2 factors of b. So it's missing this extra factor of b and the factor of 5. So I'm going to multiply by 5b. And so that's made the common denominator for both of our fractions. So that 15a squared b cubed is now the denominator for both of these. See? 15a squared b cubed, 15a squared b cubed. They now both have that denominator, which means I can write it as one fraction with that denominator. And I'm probably going to write out more steps than you guys would in this situation, but what I'm trying to do is train us for the harder problems. So if you're annoyed by the amount of steps I'm writing out, then just think about you're good, and this will help us with the future. So this is what it looks like right now. There's a reason why I'm writing it like this, I promise. So here's what's happening. When this becomes one fraction, the denominator is common and we have this. And now we need to take this added with this. I wrote it like this for a reason because you guys are going to write it like this when you're doing some other things, and you're going to be very tempted right now to start canceling some things out, okay? See how those sets of parentheses are there? It makes you feel like those factors are ready to be canceled, right? And so a lot of people are like, oh, 3a and 15, 3 and 15 cancel out. Why can the 15 not cancel with the 3 right now? Okay. Good. It looks like a factor right here, but then later on it's being added with something else. That is something I cannot cancel. We have to wrap our head around that, okay? If that is later being added with something else, we cannot do it. Only if it is all contained in something and that something only is doing multiplication with everything else up there, then are we okay with canceling it out. So I wanted to write it like this so that when you guys see it like this, you don't start canceling stuff out. I wanted you to see like we're just not done yet. We have to now do a bunch of work in the numerator, okay? So we're going to do a bunch of work in the numerator. So I'm going to multiply these together. And I'm going to multiply these together. And if there's like terms, I'm going to add them together. So 2x times 3a is 6ax. 4y times 5b is 20by. And I have that common denominator. And again, when I look at this, sorry guys, this is a b, not a 6 right here. So when I look at this, the denominator is in its factored form. Those things are factors. They're ready to be canceled if they have common factors in the numerator. The numerator is not in a factored form. Right now, the numerator is considered one factor. You can't cancel anything out of there unless it is literally a 6ax plus 20by. That's all connected right now. That's how it is. So the last thing you want to do, even though we've done an addition problem, we're done with the addition. But now once you get it into one fraction, it becomes a simplifying problem, right? Like, can I reduce this fraction? And so it becomes a problem like we were doing yesterday. If I want to check if this can be simplified, I need to check if I can factor this right here. And that numerator is not a quadratic or anything we've seen like that before, but it does have a common factor, right? 6 and 20 are both divisible by 2. So I'm just going to pull that out, look and make sure it doesn't do anything, and then decide if I'm done or not. So if I pulled out the 2, it looks like this. So I have a lot of factors in the denominator. In the numerator, I have 2 factors. I have one big factor, 3ax plus 10by. There is not another 3ax plus 10by in the denominator. So I cannot cancel out any of that. That is one factor. It has to cancel out the whole thing or nothing. Nothing can be canceled out. This is a factor of 2. If there was another factor of 2 in the denominator, we could cancel it out. Unfortunately, 15 only has factors of 3 and 5. So it's not going to cancel with the factor of 2, so we're done. So we could have technically left it like this, or we can leave it like this, but it is important you at least do this last step and analyze whether or not something can be canceled, or you'll leave something that's maybe, it's like leaving 6/12 in your answer instead of 1/2 or something like that. We want to reduce it at the end. So you can leave it either way. But that's kind of the idea behind what we're doing. And it won't take you guys as long as we are walking through this, but I'm trying to be really thorough to try and avoid the big mistakes we see people make when we're dealing with these rational functions. People are just canceling things out like crazy. We want to make sure we're really focusing on just canceling factors when it's appropriate. Okay? Any questions on what we did here? So are we okay with taking the step from like numbers that we did on the backboard together to like, okay, this has some variables in it, but nothing being like no extra terms or anything. We didn't have to do any of that stuff. Right? And then we're going to look at this part B, which does have extra terms and stuff in it. All right. So we look at part B, okay? Right now, when you look at it, each denominator only has one factor, but the factor is a trinomial. Trinomial because it has 3 terms, okay? But right now, these are just one single factor, okay? So you could build a least common denominator and just use all the factors, but that's like taking what we did in the back and making the least common denominator 18 times 12, like a really big number just because you know you need 18 and 12, when really it could have been smaller. And the reason why it's extra important with the polynomials to pick the smaller one is if you did pick both of these and you tried multiplying them together, okay, you're going to have a polynomial of degree 4 with lots of terms in it, which if that's your only choice, that's fine. But we're going to break these down first and see if they already have some common stuff before we try and just assume we have to use both of these big things. So we want to, just like I did in the back, how I rewrote 12 as like 2 times 2 times 3, and I rewrote 18 as 2 times 3 times 3 to try and look at those factors. That's what we want to do with these denominators. Okay, so I want to rewrite each of these. So this x squared plus 5x plus 6, it does actually factor as x plus 3 times x plus 2. Is there a bug over there? No? Oh. Oh, my poster keeps falling down. Is it watching you? It's keeping an eye on your face for me. Is that okay with everybody? So I'm just breaking it down into its factored form instead of seeing it in its bigger, complicated form. And now I'm going to do the same thing with x squared plus 4x plus 4. That becomes x plus 2 times x plus 2. If you want to write x plus 2 squared, that's fine. I'm writing it out for our purposes today so you guys can see all of the factors that are there. Okay. Now, we just really have to make sure we're thinking about each factor, meaning I'm not thinking about this x ever as a piece on its own. When I'm thinking about factors, this x is part of this plus 3. This is x plus 3. It is one group. It is one factor. It travels together. You can't separate it apart to cancel anything or anything like that. So now I'm going to try and figure out the least common denominator. Okay. All right, so somebody look at the first denominator and tell me what factors have to be in my least common denominator based on the first fraction. What do I have to have in my least common denominator? An x plus 3, okay? And what else? And an x plus 2. Do you guys see where Brandon's pulling that from? He's literally just looking at the two factors that are in the first denominator and saying, well, if I'm going to make common denominators, this one already has these two pieces, it better have those two pieces, okay? So then we look at the second fraction. The second fraction has in its denominator 2x plus 2's. Look at what we have so far as our common denominator. We have 1x plus 2, but we don't have that second x plus 2, okay? So we're going to put in another factor of x plus 2. This is going to be our least common denominator. So is everybody okay with looking at the two fractions up there? Can you understand why we would want to make them have a common denominator and why that common denominator would be a factor of x plus 3, a factor of x plus 2, and another factor of x plus 2? Okay. Any questions about why we're choosing that as the least common denominator? Are we sure? All right, so then let's make the least common denominator. So we actually need to turn the denominator of each fraction into the thing we said it should be. Okay, so when I look at the first one, it has 2 of the factors, but it's missing that extra factor of x plus 2. Oops. So I'm going to put in an extra factor of x plus 2. And that's okay as long as I also multiply the numerator. And I'm going to go like this. I know it looks a little silly. I'm just trying to remind myself that whatever's there, because what if this said like x plus 5? I don't want you guys to think this is just multiplying the x. It's multiplying the entirety of what was in that numerator of that fraction. Okay? The second fraction already has both the x plus 2's, but it doesn't have a factor of x plus 3. So we're going to include x plus 3 in that denominator. Okay, so what we've made right here is we've made a fraction where we know the common denominator is x plus 2, and x plus 3. Leave it in its factored form because when you're done adding, you want to simplify, right? And to simplify, we want to cancel factors. So just let that denominator kind of hang out through every step in its factored form until you're ready to look at those factors at the very end and see if anything cancels out. Okay? Then what we have going on in the numerator, the first fraction has an x plus 2 that needs to be multiplied by an x. That needs to be added with the second fraction that has a 2 that needs to be multiplied by an x plus 3. Now, this is extra tempting. Can I start canceling out this x plus 3, this x plus 2? Can I cancel any of the factors from the numerator right now? No, because those factors might look like they're factored, but really they are being added with some other factors. So we actually have a lot of work to do right here. We have to finish simplifying all of this stuff. We have to actually do the multiplication and the addition to get everything how it's supposed to be, and then see if it actually factors. Because this looks factored, but it's not. It's not a bunch of things multiplying each other. It's a couple things multiplying, and then being added together. Okay? So you actually do have to do some addition. So we're going to go ahead and distribute right here the x to the x plus 2. And we're also going to distribute this 2. And my denominator is just there. I'm writing it every time. A lot of people don't write it, and then they give me an answer on the test. It's not even a fraction. It's literally just all the work they did in the numerator because they didn't write their denominator. It's hard for me to give you a lot of credit that way. So just make sure you're keeping track of what you're doing. And then these two terms can be combined together. So I'm going to combine them together. Oops. Now I've done all of the addition, right? I'm done actually adding together all of the terms. That's when it becomes a simplifying problem. So if you're doing an addition or subtraction problem, please make sure you actually do the addition or subtraction before you decide to make it a simplifying problem. So now it's a simplifying problem, and right now the denominator is written in a way that it has 3 factors, but the numerator is written in a way that it has how many factors right now? 1, right? 1 super complicated factor, but you can't cancel anything from this numerator unless you can see an entire group somewhere that is literally x squared plus 4x plus 6. You can only cancel that entire package, nothing else. So that doesn't exist down here right now. This looks like it may be factorable. So now is where I would try to see, does this factor so that I can cancel some things out some more. So does x squared plus 4x plus 6 cancel or factor? The multiples of 6 are either 6 and 1 or 3 and 2, right? Is there any way for those to make 4? No. So this doesn't factor at all, and I can't cancel it out, so this is my final answer. And you guys don't need to multiply out that denominator, especially think about your goal as you're working. If my goal is to later simplify, I don't want to multiply it all out and try and refactor it later. It would be like a cubic, okay? Any questions about what we did here? So like, do we look at the problem? Do we know how we got the LCD? Do we know how we changed it into 1 fraction? Do we understand why we didn't just start canceling stuff right away? That we actually had to do the addition in the addition problem before we could go and try to simplify things, okay? So make sure we're paying attention to that. All right, and then we're gonna look at part C. It's the same kind of idea. So the denominators here, again, I'm always going to try to factor them first, because if they have something in common, I don't want to multiply extra of that stuff in. With numbers, it might be like, oh, it's just a little extra. I can reduce it at the end. But with polynomials, if you multiply too much extra stuff in, you might end up with like a quartic or a quintic that you can't see how it's factorable because you multiplied so much extra stuff in. So you really want to make sure you're always picking the least common factor. So this first denominator only has 2 as a greatest common factor, and the second denominator has 4. All right, so looking at them written in that format, so I can see all the factors that they contain, what should be our LCD? Okay, so it's got to have a factor of 2. Emily? It's got to have a factor of x minus 3. So far we know it needs to have a factor of 2. It needs to have a factor of x minus 3. What else? Okay, so I hear 4, another factor of 2 basically, right? Like we can think of 4 as being 2 times 2, and we already have one of those 2's. So we just need to multiply an extra 2 in there. Is that okay with everybody? So overall our LCD is 4 times x minus 3. Which means that second fraction already has all of those factors in its entirety. It has the common denominator already. I don't have to multiply anything extra in it. But the first fraction needs to be adjusted by a factor of 2. So I'm going to multiply in an extra factor of 2. When you do that, remember that 2 is multiplying the entire numerator of that fraction, the x minus 5. So our common denominator is 4 times x minus 3. And in our numerator, we have 2 that needs to multiply x minus 5. That needs to subtract the x minus 7. This is a subtraction problem. It's really important that you understand you're subtracting everything that was in the numerator of the next fraction, because when it's not just a number, this minus sign is going to distribute to each of these and affect whether they're positive or negative. So you'll get the wrong answer if you're not paying attention to your signs really carefully there. So now we're not going to cancel anything yet, okay? So we have our denominator, because we haven't actually done the subtraction yet. Do you guys see that? We haven't actually subtracted or added anything, so we shouldn't be in simplifying mode until we've actually finished adding and subtracting. To do that, we're going to distribute this 2 here. So that would be 2x minus 10, and this minus is going to get distributed here. So it'd be minus x and plus 7. And so when I combine those like terms, 2x minus x would be x, negative 10 plus 7 would be negative 3. Now that I'm done with the subtraction, I can go into simplifying mode. So is there anything here that I can simplify or cancel out? Brandon? The x minus 3. Do you guys see that? So this x minus 3 is its own factor. It can't be factored further. But it has one exactly like it down here. That group can be canceled. What are we left with when we cancel that out? 1/4, really good, okay? A lot of people are like, oh, everything's gone, it's just 4. Nope. Okay, the denominator is now a factor of 1, and this is a factor of 4, and we're left with 1/4, okay? All right, any questions on any of those ideas? No? All right, so let's look at a slightly more complicated version of these like we did yesterday. I'm actually going to have us do the try this one instead of the example 2. Okay, I think that's all we have to do today. We're going to do this one. All right, so these complex fractions, remember, are just multi-part problems written in a vertical way when we're probably much more used to seeing them written in a horizontal way. So first step, if these bother you, can be to write them in a horizontal way. So this bar, remember, is saying division. So I have this addition problem in the numerator divided by this giant fraction in the denominator, okay? So what this can become is this addition problem divided by this giant fraction. Is that okay with everybody that this notation means the same thing as what I've written right here? So when you think order of operations, okay, it's really important that because this was all in the numerator, it's like grouped together. It's like using your calculator. If you guys went to put something in the calculator, let's say you had 3 plus 5 divided by 2 and you didn't know how to do that and you wanted to type it into the calculator. You cannot type 3 plus 5 divided by 2. If you do that, what would the calculator do? It would do 5 divided by 2 first. It's been programmed to do order of operations, and then it would add it with 3. If there's more than one term in the numerator or in the denominator of a fraction, you need to put parentheses around it so that whatever machine you're using understands that those were all part of the numerator. So same idea when we write it out horizontally, and the reason that's important is because you need to make this one fraction before you can start canceling things out, right? Because we can't cancel factors that are being added or subtracted with something else. So even if we had an x plus 2 over here, we can't cancel it with this x plus 2 because this fraction right now is being added with something else. We don't have it written in a factored form yet for us to be able to do that, okay? So our first focus is going to be to complete this addition problem, okay? What should be the least common denominator for that addition problem? Look at the first fraction. Brandon knows. I know he knows. He's told us a lot. Okay, look at the first fraction. Look at the second fraction. Take a second in your group and you guys decide what the LCD should be for that fraction. All right, so someone tell me, what should our LCD be if we want to add those two fractions together? Jake? Good. They were already in their factored forms. They were totally different factors. So they aren't like our 12 and 18 back there. They didn't have anything in common. They were just two totally different things. So we need to contain them both in our least common denominator. So this first fraction needs to get a factor of x minus 5 because that's the one it's missing. And the second fraction needs a factor of x plus 2. And so the way this is going to be looking is 1 is going to be multiplying x minus 5. It's going to be added with a 1 that's multiplying x plus 2. And that's over the common denominator that contains both an x minus 5 and an x plus 2. Can I cancel out these x plus 2s and x minus 5s that I see here? No, because the numerator ones are not multiplying each other. They are adding with each other. You are trying to do an addition problem right now. You have not yet done addition. So you need to finish the addition before you decide if they can combine together. So I'm just being super thorough. I know you guys know what 1 times all these things are, but you would distribute that. So we'd have x minus 5 plus x plus 2 over x minus 5 times x plus 2. And when we combine the like terms, we get 2x minus 3 over x minus 5 times x plus 2. Is everybody okay with the addition problem portion of it? We're not done with this problem. All we've done is turn the numerator into one fraction rather than multiple fractions. Okay. So what's happening to this fraction? So this was just from the addition part. It became that. It still has all this stuff happening to it over here. So it's still being divided by this. So now this becomes a problem like we worked on yesterday, right? Now we are in the world where we don't really have to do any more addition or subtraction. We've completed that portion of it. And instead we're looking at division, which falls into like the division, multiplication, simplifying idea. So what do we remember yesterday about doing the division with fractions? What do we have to do? Flip it and change it to multiplication. And again, I wouldn't multiply out the one that's already been factored because remember, the way we simplify fractions is by canceling factors. So if there's already a factored piece of it, I want to keep it that way, factored. All right, so everything in the first fraction is factored for us, but we want to factor everything that's in the second fraction. So x squared minus 3x minus 10 factors as x minus 5 and x plus 2. And 2x squared minus x minus 3 factors as 2x minus 3 and x plus 1. And I am assuming, I know I'm doing the factoring part fast. I'm assuming you can go do the factoring part. I'm not assuming it's as fast as me or the same method I'm using, but I am assuming that that's not what I'm going through right now. That this is it. If you need me to go through that, you just need to come in at a different time and we can sit down and go through the factoring. All right, what can we cancel out? Everything is now in factored form, right? Now in the numerator, if we look, I see 1, 2, 3 factors. Those are all things that when grouped together, this guy, when looked at as a group, only participates in multiplication with the other things they've grouped together. And in the denominator, I see 1, 2, 3, 4 factors. Okay, so those are the things I can possibly cancel, and so we want to cancel all the common ones from any numerator and any denominator. So 2x minus 3, x minus 5, x plus 2. And so what we have remaining in our numerator, remember, is 1. When you're canceling out factors, you still have a 1 left there when you canceled everything out. And x plus 1 in the denominator. All right? Is this okay with everybody? All right, I'm going to put up a subtraction problem for you guys to do like we did yesterday, just something separate from what's in the note guide so you guys can try to do something extra.